Welcome to Void Realities. If you're awake when the world sleeps, you found the right place. Here, the lines between dreams and reality blur, and you can drift away into a world that feels like it's just for you. No rush, no pressure. Just a space for you to unwind, let go of the noise, and find calm in the quiet of the night. Whether you're seeking peace, wonder, or something to help guide you into sleep, Void Realities is your escape. Sit back, relax, and let your mind wander to the edge of the unknown. Welcome to the void. Quantum entanglement, how particles whisper across space. A thread between stars. You begin with the idea that everything is connected in ways you cannot see. Two particles once close keep a secret line of communication across impossible distances. It is not sound, nor light, but something quieter than silence. You lean closer, wondering how the universe holds such invisible threads. It begins in stillness, a darkness so deep it feels like the beginning of time, before stars, before light, before anything moved. In that quiet, the universe hums, not a sound you can hear, but something you can feel, like the faint vibration of a string drawn tight. You imagine this string stretching between 2 points in space, not a rope, not even a beam of light, but a connection so fine it weaves through the fabric of reality itself. Two particles once born side by side share this thread, and even when they drift apart, one perhaps pulled toward the heart of a distant galaxy, the other carried into the emptiness between, the thread does not break. The first time you hear this idea, it feels like a poem more than physics. But it is real. Measured in careful experiments, repeated until even the most skeptical eyes admit, some bonds do not fade with distance. You picture it more clearly. Two tiny sparks of matter, no bigger than a whisper of dust floating in the void. They are not tethered by a chain or a beam. Instead, they share something more intimate. Their states, their spins, their secret identity. If one changes, the other changes too, instantly, as if space between them does not exist. It is called entanglement, and it tells you something subtle about the nature of reality. Distance is not always what it seems. The thought is comforting and unsettling at once. Comforting because it suggests nothing is ever truly alone. Unsettling because it challenges what you thought you knew about how the universe works. We are taught that information must travel, like a message in a bottle, or light from a distant star, taking time to cross the gulf. But here, there is no travel, no delay, only change, and the other particle knowing. You imagine standing on a hill at night, watching the stars. Each point of light seems so far away, yet the darkness between them is not empty. It is woven with unseen threads. The space you thought was silent may be alive with quiet conversation. There is a story that physicists sometimes tell, not in textbooks but over coffee when the air is lighter. They speak of two gloves placed in separate boxes, one sent across the world. Open one box and you know instantly what is inside the other. But in quantum entanglement, the glove's handedness is not decided until you look. When you peek inside one box, the other glove becomes its match in that moment, no matter how far away it is. It is not that one glove sends a signal. That would take time and perhaps break the rules of light. It is that the gloves, like the particles, are part of a single story, a shared existence. To change one is to change the whole. The poet in you loves this. The scientist in you wants proof. And proof exists. In labs across the earth, photons and particles of light are entangled, then sent to opposite corners of a city or even between mountain tops. Measure one and the other responds instantly, every time. You close your eyes and let the idea expand. If particles can remain bound like this, perhaps so can other things. Perhaps the atoms in your body, born in the fires of ancient stars, still carry threads to their twins scattered across the cosmos. Perhaps the feeling of connection you sometimes have to a place, a person, a moment is not just poetry, but physics whispering under your skin. And yet, the mystery deepens. What is this thread made of? Not light, not matter, not anything that can be plucked or seen. It is a relationship written into the mathematics of the universe itself, a reminder that reality is not built from isolated blocks, but from relationships between them. You imagine the universe as a great loom, every particle a knot in the weave. Some threads are close and obvious, the pull of gravity, the warmth of sunlight on your skin. Others, like entanglement, are so fine they almost vanish from sight, until the right light catches them and they shine for an instant. The thread between two particles may be invisible, but it is unbreakable. Even when worlds, stars, and galaxies shift, the connection remains. Perhaps it is this same principle, scaled beyond the quantum, that lets you feel someone's absence across an ocean, or sense their presence in a silent room. You sit with this thought a while, feeling its quiet comfort settle into you. Some distances are illusions. Some separations are not real. Some things remain bound, even when space insists otherwise. But if entanglement is real, then a question rises like a soft tide when one particle changes and the other instantly knows. How does the knowing happen? That is the next step on this journey, to watch what happens when one moves and the other follows, as if to say, I am still here with you. When one moves, the other knows. You imagine two dancers who once held hands, now on opposite ends of the world. One spins, and the other, without seeing, mirrors the movement instantly. In quantum physics, this strange dance is not just a metaphor. It is measured, tested, real. You let the mystery settle in like the slow turning of planets. It begins as a picture in your mind, two dancers on a vast dark stage, so far apart that no music, no light, no whispered cue could ever reach them in time. And yet when one lifts a hand, the other's hand rises too. When one spins, the other turns with perfect precision, as if their bodies are still joined in an invisible rhythm. This is how entangled particles behave. No matter how far they drift, across a lab table or across the galaxy, their motions remain bound together, not through sight, not through any signal we can trace, but through a link that space itself seems unable to sever. You picture them before they parted, close together, born from the same event. In that first instant, their identities were tied, their spins, their orientations, their quantum states. Like two coins flipped in the same moment, not yet showing heads or tails, only the possibility of both. Then they are carried away. One might be sent toward the mountains, the other toward the sea. The space between them grows into kilometers, light years or more, and still if you measure one, if you finally ask it to choose, the other chooses too instantly, not a beat later, not with delay, at the very same moment. The mind wants to ask, how? The question echoes like footsteps in an empty hall. Einstein himself asked it, unsettled by its implications. He called it spooky action at a distance, as though adding the word spooky could soften the strangeness. He believed nature must have a hidden plan, something unseen, some hidden variables, carrying the message between them. But experiment after experiment stripped those possibilities away. You imagine a scientist at a control panel, watching two screens that track entangled particles miles apart. A button is pressed to measure the first particle's state. It chooses, and the second state appears on the other screen instantly. No time for a signal to cross the gap, no delay for light to travel. It is as if the gap does not exist. And so you return to the dancers. Perhaps the space between them is not space at all, but a kind of folded fabric, bringing their movements together. Or perhaps they are not two separate beings, but two faces of the same presence appearing in different places at once. This thought has a quiet beauty. It suggests that what we call separate may only be separate in appearance, that what we call change in one place may, in some deeper reality, be a change everywhere at once. Even here, sitting in your own stillness, you feel the analogy in your body. Your heartbeat shifts and your breathing follows. Your mind quiets and your shoulders soften. In a way, you too are an entangled system, one movement felt in another place entirely. The experiments that prove this are delicate, like balancing a drop of water on a leaf. They require shielding particles from stray influences, ensuring nothing else touches them, nothing else nudges their behavior. And still, through all that care, the link holds. Measure one, the other answers. It is tempting to think of it as communication, but it is not. No message passes between them, no signal travels through space. Instead, it is as if they share a single state, a single truth that is simply revealed in two places at once. The universe, it seems, can hold unity without proximity. It can bind things together without any visible thread. And in this quiet knowledge, a strange comfort takes root. Perhaps distance at its core is an illusion. But if they can mirror each other so perfectly, without any delay, then something else must be true as well. They must share a language we do not yet understand, a language without light, without time, without travel. And that is where the next step leads, into the stillness between signals and the strange wordless language of the quantum world. The language without light. We speak in words, whales in song, atoms in collisions, but entangled particles speak in a language with no sound and no signal. It is a conversation without time, a message that does not travel, but simply exists. You feel the quiet hum of a universe fluent in this strange speech. Every language you know begins with a sender and a receiver. One speaks, the other listens. The words travel as vibrations in air, pulses of light, movements of a hand. Even the slow creak of tectonic plates beneath the earth is a kind of language, carrying meaning from one place to another through movement. But here, in the world of entangled particles, there is no such journey. No path from one to the other, no messenger carrying a signal across the space between them. Instead, it is as if both sides of the conversation happen at once. Two mirrors reflecting the same light, even when no light shines. Two ripples on a still pond that rise together, though no stone has fallen. This is the language without light. No photons, no sound waves, no medium in between. A form of connection so complete it needs no bridge at all. You try to imagine what it would feel like to speak in such a way. Not to send your thoughts outward, hoping they arrive, but to exist in such deep unity with another that your change is their change, instantly, inevitably. Like breathing in and knowing without doubt that somewhere far away another chest rises in perfect rhythm with yours. In human life, the closest we come may be those fleeting moments when you and another person speak the same thought at the same time, or when a deep silence holds meaning without a single word. But here, it is more than shared mood or coincidence. In quantum entanglement, it is law. It is written into the mathematics of reality itself. Physicists have tested it with extraordinary care. They entangle two particles and send them far apart, far enough that light could not carry information between them in time. Then they measure each one at the same instant. The results match every time, not because they agreed beforehand, not because one told the other, but because, in a way we still cannot fully name, they are not truly two. It is not communication in the way we know it. No message leaves one and arrives at the other. Instead, it is a shared existence, like two ends of the same branch swaying together in the wind, even if you can't see the wood between them. Einstein objected to this idea. To him, a universe where something could be known without a signal seemed impossible. But as experiments grew more refined, the results refused to bend to expectation. The particles continued their strange, synchronized dance, and here you pause. You imagine the very fabric of space not as empty but as woven, a tapestry where threads pass unseen beneath the surface. 2 points may appear far apart, but if you lift the cloth and fold it, they touch. Perhaps the particle's language is spoken across that hidden fold. There's a tenderness to the thought, a reminder that not all connection depends on light or distance or time. Some bonds are simply part of what is, quiet, constant, unbreakable. You sit with this image, a conversation that does not travel, a knowing that does not begin or end. The universe, it seems, can be fluent in silence. But this leads to another question, one that lingers like the fading ring of a bell. If they speak without light, without time, without movement, then where exactly does this connection live? And to answer that, you must follow the thread back to its very beginning, to the moment when two particles are born together, and the universe decides they will never be apart. Born together, bound forever. Some connections begin at birth and never fade. Two particles created in the same instant carry a bond that space cannot stretch. It is as if the universe sews them together with invisible thread. You hold this image gently, like a secret folded into your palm. Every story has a beginning, and in quantum entanglement, the beginning is everything. Two particles are born together, not in the soft way seeds sprout in soil, but in an instant, as though the universe pressed them from the same mold and set them drifting into being. It might happen when a single particle splits into two, or when a flash of light scatters into twin photons. In that moment of creation, something is written between them, a shared blueprint of their properties, a silent agreement that their fates will always match. You picture it like two leaves emerging from the same branch. At first they grow side by side, touching in the same breeze. Then a wind pulls them apart, carrying them to distant corners of the sky. And yet, even in different worlds, the pattern of their veins is mirrored. Whatever happens to one will be reflected in the other, no matter the gap between them. In the quantum world, this is not metaphor. When two particles are born together, their identities are not separate. They are written in the same ink, on the same page of reality. Separate them and the page does not tear. It simply folds. Physicists call this a shared quantum state. It means that to describe one particle, you cannot avoid describing the other. You can't tell the full story of one without including the other's details. They are a single system, even when miles apart. The most remarkable part is that this bond does not weaken. Distance, time, even obstacles in between, none of it fades the connection. You could send one particle to the far edge of the galaxy and keep the other here on Earth, and still, when one changes, the other will echo the change instantly. It is a kind of loyalty the human heart understands, even if the mind struggles to explain. A promise that says, we began together, and so we remain together. Sometimes you wonder if the universe does this at larger scales too. If the stars themselves remember the clouds they were born from, if your own atoms still hum in tune with the places and moments they came from, the heat of an ancient sun, the dust of a star long gone. This thought brings a quiet warmth, like discovering that home is not a single place, but a thread you carry wherever you go. In the lab, scientists can recreate this birth over and over. They let one particle decay into two, or shine a laser through a crystal that splits light into entangled pairs. Each time the particles leave together, already carrying the invisible stitch between them. It is as if the act of being born from the same moment leaves an indelible mark. You hold this image gently, two tiny sparks drifting apart, yet always sharing the same heartbeat in the language without light. It is not a choice they make, it is simply what they are. And so you begin to see that entanglement is not just about mysterious signals or strange physics. It is about origin, about the moment when two become one and one becomes two without ever truly splitting. But if they are born bound forever, there must be a way to prove it, to listen for that bond across the gulf of space. And that is where the journey turns next, to the experiments that dared to listen for the whispers of the universe. The experiments that listened scientists set up delicate instruments in distant places. They watch, measure, and wait for particles to whisper their truth. Across mountains, deserts, and oceans, the results are always the same. You realize this is not a rumor, but the universe speaking in fact. It begins in quiet rooms filled with light too faint for the human eye. Lasers hum softly, lenses gleam in the darkness, and mirrors tilt with the patience of years. In these rooms, scientists are not trying to force the universe to reveal its secrets. They are waiting, listening, like placing an ear against the shell of a seashell and hearing the ocean hum from far away. To test entanglement is to test the impossible. You must take two particles, born together in the same flash, and send them to places so far apart that no light could carry a message between them in time. Then you measure them instantly in the same moment and see if they still answer each other's call. The first attempts were small, tables in cramped laboratories, equipment cobbled together with care and precision. Yet even then the results startled the world. Two photons, split from the same source, showed matching measurements more often than random chance could allow. Not just sometimes, not just often, but in ways that matched the strange, exact predictions of quantum mechanics. Still, there were doubts. Perhaps, some said, the particles were somehow agreeing ahead of time, or perhaps there was a hidden path for information to pass between them unnoticed. So the experiments grew larger, more daring. In 1972, John Clauser and Stuart Friedman stretched the distance between their entangled photons, sending them meters apart, a vast separation for such delicate things. The results? Still the same silent agreement. By the 1980s, Alain Aspect in France refined the method even further. He used rapid switches to change the way the particles were measured while they were already on their way. Too late for any hidden signal to pass between them. And still, the particles behaved as though they knew exactly what the other had experienced. The most breathtaking test came decades later. In 2015, teams in the Netherlands, Austria, and the United States performed what are called loophole-free experiments. They placed detectors in separate buildings, linked only by the brief birth of entangled particles. The distances were far enough that even light, the fastest thing in the universe, could not cross the gap in time. Every test spoke the same quiet truth. When one particle chose, the other chose too. Instantly. You imagine standing between those two detectors, the night air cold, the stars above ancient witnesses. Somewhere a laser pulse sends twin photons flying in opposite directions. They race away far faster than you could follow, and in less than a heartbeat, their answers arrive. No wire, no wave, no messenger between them, just the quiet, simultaneous knowing. It is in these moments that science feels almost like listening to music you cannot hear, only seeing the patterns it leaves behind. The detectors are not catching the words of the particles, they are catching the harmony in which they move. And the harmony is always there. Across mountain tops in the Canary Islands, across cities in the Netherlands, across oceans in experiments with satellites passing high above the Earth, the results do not change. What began as theory is now fact, solid as stone and repeated across the world. The universe is not as separate as it appears. Some connections do not require distance to vanish before they speak. You let this truth settle into you, warm and steady. The experiments have done more than prove entanglement. They have shown that reality itself can hold hands across space. But in proving it, they also uncovered something else. Not everyone is comfortable with what the results mean. Even the greatest minds sometimes resist the shape of a truth they cannot reconcile. And so the story turns to one such mind, a man who gave us the shape of modern physics, yet could not bring himself to trust this quiet whisper between particles. Einstein's quiet discomfort. Einstein called it spooky action at a distance, a phrase both playful and unsettled. He believed the universe should not behave this way. Yet experiment after experiment whispered back, it does. You imagine him staring at the stars, wondering what he had missed. There is a certain irony in finding discomfort inside your own masterpiece. Einstein had given the world relativity, the idea that space and time themselves bend and stretch, that nothing moves faster than light. It was a vision of the universe that worked with clockwork precision, where cause and effect were loyal companions, and no message outran the speed limit of reality. And then came quantum mechanics, a theory so strange it felt less like a clock and more like a dream where possibility ruled until observation pinned it down. Einstein admired its predictive power, but in its tangled depths he found something that felt wrong. Entanglement. Two particles acting as one, no matter the distance. A change here mirrored instantly there. It seemed to break the rules he had so carefully written. He gave it a name, spukhafte Fernwirkung, spooky action at a distance. The words carry a touch of humor, but underneath them is resistance. Einstein could not accept a world where influence could leap across space with no signal, no journey, no respect for the speed of light. To him, this could only mean one thing. Our understanding was incomplete. There must be hidden variables, unseen details, tiny messengers carrying information behind the scenes, like whispers in a play that the audience never hears, but that guide the actor's steps. In 1935, Einstein, along with Boris Podolsky and Nathan Rosen, published a paper now famous as the EPR paradox. They argued that quantum mechanics was not wrong, but unfinished, a clever tool that worked in practice, yet missing a deeper, truer description of reality. You picture him at his desk, papers spread like snowdrifts, pipe smoke curling in the lamplight. He is not angry. He is puzzled, trying to thread the needle between the precision of relativity and the unruly truths emerging from quantum theory. And yet history would prove stubborn. In the decades that followed, John Bell's work and the experiments it inspired would corner the EPR argument. The hidden variables, if they existed, could not behave in a way that saved Einstein's vision without breaking other fundamental rules. Reality, it seemed, was committed to its spookiness. Still, there is something deeply human in Einstein's unease, to have shaped our understanding of the cosmos, and yet to look upon this strange, silent connection between particles and say, no, not like this. Perhaps he feared what it would mean for the nature of separateness. Perhaps he simply could not let go of the comfort that distance means independence. After all, if entanglement were true, then the boundaries we believe in, between objects, between moments, between selves, might be less solid than they appear. And so you imagine him walking under the night sky, the stars wheeling overhead, his mind carrying the weight of both wonder and doubt. Perhaps he knew that science often grows from discomfort, that unease is a seed that forces us to keep asking questions. Even now, the phrase he coined still clings to the phenomenon, a reminder that even the greatest minds wrestle with mystery. And mystery, when we lean into it, can open into something wider, a vision of the universe not as a scattering of lonely points, but as a whole that refuses to be alone. A universe that refuses to be alone. In the smallest spaces, separations are illusions. Entanglement suggests that distance may not be as real as we think. Perhaps the universe is not a collection of lonely parts, but a single, breathing whole. You feel a soft comfort in that thought, like holding hands in the dark. When you first look at the night sky, it is easy to believe in separation. Stars appear as scattered islands in a black ocean. Planets drift in their own paths, each turning alone in the silence. The spaces in between seem vast and empty, and your own life feels small against it all. But the quantum world tells another story. It suggests that the idea of apart is not always true. That what you see as separate may, in a deeper way, be parts of the same whole, pieces of one unbroken fabric. Entanglement is the clearest hint of this. Two particles, no matter how far they are flung, remain in step with each other. It is as if the space between them is not a gap, but a hidden fold in reality. From our perspective, they are apart. From the universe's perspective, they are still together. You picture the cosmos as a single, endless sheet of cloth. Galaxies are patterns woven into it, stars are the points where threads cross, and the spaces between are simply the stretches where the weave is loose. Touch one part of the cloth, and the movement travels everywhere, whether you can see it or not. This is not just a poetic thought. Physicists now suspect that the very geometry of space-time might be shaped by quantum entanglement, that the strength of these invisible connections could knit the structure of the universe together, holding the cosmos in one continuous whole. It is a comforting image, a universe that refuses to be alone, a reality in which nothing is ever truly isolated, not a star, not a planet, not even you. And in that comfort, there's also a question. If the universe is one connected whole, then perhaps our idea of distance, of being far from someone or something, is more about perception than truth. Maybe the feeling of connection you have with a distant friend, or the way a place you've never been can still feel familiar, is part of the same deep principle that binds particles across space. The thought rests inside you like warm light. It softens the edges of loneliness. It suggests that being human is not about existing as a single point, but as part of a vast invisible web, one that stretches from your own heartbeat to the farthest stars. And yet this web is not obvious. It hides under the rules we think we know, rules about how information should move, how cause and effect should work. Entanglement bends these rules until they blur, reminding us that reality can be both stranger and more beautiful than we expect. Which brings you to the next step of the journey. What happens when the rules themselves are challenged and the universe reveals it was never playing by them to begin with? Breaking the rules. That weren't rules. We once thought information must travel through space to arrive. Entanglement bends that rule until it disappears. It is like finding a shortcut that was always there, just unseen. You begin to wonder what other rules the universe hides. All your life you've been taught that every message, every influence must travel from one place to another. A ripple spreads from the stone dropped into water. A voice moves through air carried by vibrations. Even light, the fastest messenger we know, must follow its own speed limit, racing but never infinite. It's a rule that feels so obvious you forget it's a rule at all. Cause happens here, effect happens there, and between them lies the journey. Entanglement breaks that. It doesn't just bend the rule, it removes the need for the rule in the first place. Two particles, separated by any distance, seem to know each other's state without sending anything across the gap. No signal, no waiting, no travel at all. It is like watching two clocks in different cities tick perfectly together without ever being wound, without a wire, without a satellite connecting them. You could move one to the far side of the galaxy, and still, when one turns its hand, the other moves in the same instant. For centuries, science has been about finding the rules, naming them, and testing their limits. And here comes something that says, the rule you thought was, there was only a shadow of a deeper truth. The deeper truth is unsettling, that reality might not be built from pieces exchanging messages, but from a single inseparable whole, where change in one part is already change everywhere. Physicists have tried to explain this without breaking the old rules. They've searched for hidden variables, imagined secret messengers slipping through space unseen. But experiment after experiment closes those doors. The universe simply shrugs and shows that the connection was never sent. It was always shared. It's as if you've been walking through a city thinking you need streets to reach another building, only to discover a hidden hallway that's been there all along, linking places directly without crossing the distance between. When you think about it, many of the rules we live by are like this. We believe time always moves forward, yet relativity shows it can stretch and slow. We believe nothing can be in two states at once, yet quantum mechanics insists particles live in possibilities until we look. Entanglement doesn't just give us a new fact. It changes the map. It tells us that the boundaries we see in space and time are not walls but curtains, and that sometimes the universe lets you peek behind them. You sit with this thought. If this rule wasn't really a rule, then how many others are waiting to dissolve? How many things we know are just temporary scaffolding built to give us a sense of order until a truer picture appears? The air feels different now, as if the space around you is less of an emptiness and more of a living thing, woven with quiet threads you cannot see. And you can't help but ask, if such threads can connect particles instantly, could they be used for more than proof and wonder? which is where the next step of this journey will lead. From the realm of pure theory into the world of technology and transformation, where the whispers of particles begin to shape our human future. From lab to life, entanglement is not only a curiosity of physics, it is the root of quantum technology. Secure communication, quantum computing, and sensors beyond imagination grow from it. The future hums softly in these possibilities. You picture a world quietly transformed by whispers between particles. For decades, entanglement lived mostly in the minds of physicists and in the careful pages of research journals. It was a delicate thing, coaxed into existence in dim laboratories, observed only through intricate detectors and pages of mathematical proof. It felt like a phenomenon too fragile to step outside the lab's quiet walls. But slowly, steadily, the boundary between theory and use began to dissolve. What began as an experiment to test the limits of reality is now a seed from which new technologies are quietly sprouting. You imagine walking into one of those laboratories today. The air hums with the faint vibration of cooling systems. Rows of mirrors, fibers, and lasers line the benches like instruments in an orchestra, each tuned to direct and split and guide tiny packets of light. Some of these photons will be entangled and sent down fiber optic cables, others fired upward toward satellites that pass silently overhead. And somewhere, far away, their partners wait, ready to answer instantly. The first and perhaps most transformative use is quantum communication. Entangled particles can be used to share cryptographic keys in a way that cannot be intercepted without detection. If someone tries to measure them, the delicate quantum state changes, and both sides know the channel is no longer secure. It is as if you and a friend share a pair of invisible gloves that change color the instant anyone else tries them on. Then there is quantum computing. Ordinary computers store information as bits, 0 or 1. Quantum computers use qubits, which can hold 0, 1, or any combination of both at once, and entanglement is what links these qubits into a single powerful system. The more qubits entangled, the more complex the patterns they can hold, allowing them to solve certain problems far faster than any traditional machine. And beyond computing lies a field still taking shape: quantum sensing. Entangled particles can be exquisitely sensitive to changes in their environment, opening the door to measuring time, gravity, and magnetic fields with unprecedented precision. You imagine doctors detecting illness at its earliest stages, navigators finding their way without GPS, and scientists mapping the Earth's crust in subtle detail, all through the quiet awareness of entangled states. What's striking is that these technologies don't shout their arrival. There is no explosion, no sudden leap in everyday life. Instead, they arrive like a tide. At first, just a ripple of new capability, then slowly, almost imperceptibly, changing the shape of what is possible. You think back to the early days of electricity. At first, it lit only a few lamps in a few cities. Now it hums invisibly through every moment of your life. Entanglement may be on the same path, quietly leaving the lab and weaving itself into the fabric of the everyday. Perhaps one day you will send a message across the world and it will arrive instantly, untouchable by eavesdroppers. Perhaps your devices will no longer need satellites to know where they are. Perhaps computations that once took centuries will be completed in seconds. All of it born from a truth so delicate you could almost miss it: that two particles once joined never truly part. And as you picture this future, a deeper, more personal question begins to form. If the particles in your body are still bound to their twins somewhere in the universe, what does that make you part of? That question carries you softly into the next chapter, a mirror turned inward, and the quiet possibility that you yourself are connected in ways you've never seen. The mirror inside. Your body is made of particles born in ancient stars. Perhaps somewhere their twins drift in distant galaxies, still connected in ways we cannot measure. Entanglement becomes not only a property of matter, but a story of belonging. You close your eyes feeling a universe that never quite lets go. You begin with your own breath, inhaling, exhaling, each moment pulling in air that has circled the planet countless times. The oxygen you draw now might have brushed the leaves of an Amazon rainforest or passed through the lungs of a bird over the Arctic Sea. The nitrogen may have lingered in the sky since before humans spoke their first words. Your body, too, is not new. Its atoms were forged long before you were born. The calcium in your bones, the iron in your blood, the carbon in every cell, all were made in the hearts of ancient stars. When those stars ended, they scattered their elements across space, and over billions of years, those pieces found their way here, into the soil, the oceans, and eventually into you. Somewhere far away, other fragments from those same stars still drift. Perhaps they have become part of another planet's soil, or the atmosphere of a world circling a distant sun. Perhaps they shine now in the leaves of alien plants, or rest in the heart of a comet wandering the deep dark. If entanglement can link two particles across impossible distances, it's tempting to imagine that some of your particles, born together with others in the same star's explosion, might still carry a silent connection to their twins scattered across the universe. This is not a claim science can measure for you, but it is a picture that feels quietly right. That you are not a closed system, but part of a greater whole that began long before your first breath. When you look in a mirror, you see a single contained self, but the truth is more porous, more open. Your body is a pattern, a living arrangement of particles, many of which have been arranged differently countless times before. What is you today was once ocean, cloud, forest, stone, and stardust, and one day it will become those things again. Perhaps this is the deepest mirror, not glass, but connection. You are not only what you see reflected back, you are also what you cannot see, the unseen bonds that tie you to matter and moments far beyond your reach. When you touch your hand to your chest, you are touching the memory of a star's fire, the echo of collisions older than the earth itself, and maybe the faintest whisper of particles still speaking to their twins far away. It is a thought that softens loneliness. To know that, even when you feel separate, your very structure is the result of shared origins. That you are a continuation of something vast and ancient, woven into the same fabric as galaxies and comets. And so, the mirror inside you is not a flat surface. It is a window, showing not just who you are now, but everything you have ever been and everything you are still connected to. From here, it is only a small step to see that this connection is not limited to matter. It may extend to time itself, to moments that stretch and bend, changing the way your life flows from one instant to the next. And so the journey turns toward that other sculptor of reality, the one that works alongside entanglement, time. Time's two sculptors, speed and gravity. Time is not fixed. It bends under the influence of motion and mass. Speed can stretch seconds, and gravity can slow them to a near halt. These two forces carve the flow of moments like rivers shaping stone. You step into their current, feeling time change beneath your feet. We are taught to think of time as a steady beat, seconds following seconds like footsteps on a path, each one equal, unchanging, dependable. But the universe does not keep time that way. Its clocks are not uniform. They sway to the pull of motion and mass. In physics, these two shapers of time are well known. Speed, the rush of motion through space, and gravity, the pull of mass bending the fabric of reality. Both are sculptors, and the medium they shape is the very flow of seconds. You imagine carrying a perfect clock, not one of gears and springs, but one that counts the oscillations of light itself. Now take that clock aboard a ship traveling close to the speed of light. When you return and compare it to an identical clock left behind, you'll find that yours has ticked fewer times. You have lived through fewer moments. To you, nothing felt unusual. To the universe, you have experienced time more slowly. This is time dilation due to speed. It's not a trick of perception. It's real. Your heartbeat, your thoughts, your every movement would have unfolded in a stretched version of reality. Gravity shapes time in its own way. A massive object like a planet or a star bends the space around it. That bend pulls on time as well, making seconds near the mass pass more slowly than those farther away. Place one clock on a mountain and another in a valley. The one in the valley, closer to Earth's center, will run just a little bit slower. These effects are tiny in everyday life, but they are not negligible. GPS satellites orbit high above Earth, where gravity is weaker and speed is constant. Their clocks run slightly faster than those on the ground, and engineers must account for this difference so your navigation stays accurate. It's strange to think the time you experience is shaped by where you are and how you move. You are always in your own personal current, flowing faster or slower than someone else's, though the difference is often too small to feel. And yet, when the difference grows, it opens doors to possibilities that border on the surreal. An astronaut moving fast enough or spending long enough near a massive planet could return to find years passed on Earth while only months passed for them. Speed and gravity do not just shape paths through space, they shape your path through time. They remind you that now is not the same everywhere, that moments can stretch and compress, and that the future someone else is experiencing may not match your own. These are not just abstract ideas. They are the quiet laws that guide satellites, spacecraft, and even the beat of atomic clocks. They are the reason time, like space, must be navigated with care. And as you drift with this thought, you can't help but wonder what happens when both sculptors, speed and gravity, are at work together, twisting time into shapes we can barely imagine. That is where the journey will turn next, to see how these two forces meet in the most extreme environments in the cosmos and what happens when you try to live in the time they create. Time dilation in everyday life. The bending of time isn't only for astronauts and black holes. It happens here in the world you walk through each day. Atomic clocks, GPS signals, even your own heartbeat move in slightly different tempos. You begin to notice that time's flow is never truly the same for everyone. When you hear of time dilation, you might picture the extremes, spaceships hurtling near the speed of light or the crushing gravity at the edge of a black hole. It feels distant, untouchable, something for science fiction more than daily life. But the truth is quieter. Time dilation is happening to you right now. If you could place two identical atomic clocks in different locations, even a few floors apart in the same building, you would find, after enough careful measurement, that they disagree. One ticks just a little faster, the other a little slower, because gravity and motion are always at play, even in small ways. High above you, satellites in orbit carry their own clocks. They feel less of Earth's gravity and move at steady speeds. These two effects push in opposite directions. Gravity would make their time run faster, motion would make it run slower, but the balance between them still leaves a measurable difference. Engineers correct for it constantly, or your phone's GPS would drift, sending you miles from where you actually are. Even planes in flight experience it. Take a clock on a long journey, and it will return ever so slightly out of step with the clocks that stayed home. It's not enough to notice without sensitive instruments, but it's there, written into the math of relativity. And then there's you. Every day you live in your own patch of curved space-time shaped by Earth's mass and your motion through it. Your seconds are yours alone, not exactly the same as anyone else's, though the differences are so tiny they blur into the rhythm of life. This realization is both strange and intimate. It means that time is not a universal river we all drift down together. It's more like a network of countless streams, each one flowing at its own pace, sometimes faster, sometimes slower, each shaped by where it winds and how it moves. In everyday life, those streams are close enough to seem the same. But the fact they're not, that time is personal, unique to each observer, is a quiet reminder of how deeply the universe bends around us. It's easy to think of relativity as an idea that lives only in textbooks. But here it is, woven into the signals that guide you through a city, into the clocks that keep the world synchronized, into the invisible mathematics behind every map and measurement. You are already living in a world where time is flexible, not by choice, but by nature. And though the difference is tiny, it's proof that the strange and the ordinary are never as far apart as they seem. From here, it's a small step to ask, if time bends gently here on Earth, what happens when it's pushed to its limits? When light itself becomes the clock, and the boundaries of speed and distance are tested? That is where you go next. To follow light, the ultimate timekeeper. Light as the ultimate timekeeper. Light does not tire, slow, or speed up. It moves at the same pace for everyone, everywhere. Its constancy is the ruler against which the universe measures time. From atomic clocks to the age of the cosmos, we trace our seconds by light's steady stride. You step into its path, feeling time flow with the rhythm of photons. If time is a river, then light is the current's most faithful marker. No matter where you stand, no matter how fast you move, light always reaches you at the same speed, a universal constant written into the fabric of reality. It's this constancy that makes light more than illumination. It's a measure, a clock, a standard the universe itself abides by. When you measure distance in light years, you're really measuring the number of steady beats light has taken to cross the darkness. Einstein built much of relativity on this truth. If light always moves at the same speed, then space and time themselves must shift to make that possible. Distances stretch, seconds bend, all so that the pulse of light remains unchanged. This is why we use light to keep time. The most accurate clocks we have, atomic clocks, do not tick with gears or pendulums. They tick with the vibrations of light absorbed and emitted by atoms. Cesium atoms, for example, oscillate at an exact frequency when they change energy states. Count those oscillations, and you have a second so precise that, over millions of years, it might not gain or lose more than a blink. You might not see this precision in your daily life, but it guides you all the same. Your phone, your GPS, your internet, all rely on clocks that take their heartbeat from light's unwavering pace. Satellites carry these timekeepers, aligning their signals to within billionths of a second so that your map pin drops exactly where you are. Light also keeps the universe's oldest time. When we look at the faint glow of the cosmic microwave background, we are seeing light that has been traveling for nearly 13.8 billion years, the leftover warmth from the birth of the cosmos. That ancient glow is a record, a time capsule moving through space without ever aging, reminding us of how long the universe has been unfolding. What's remarkable is that, unlike us, light does not experience time. From a photon's perspective, if such a thing could be imagined, its journey from one end of the universe to the other is instantaneous. It exists in a kind of eternal present, never feeling the stretch of seconds we live within. This makes light both our most faithful timekeeper and our most elusive traveler. We measure time by something that itself stands outside of it. A paradox, perhaps, but one that works so well it forms the backbone of modern science. And so you begin to see light differently, not just as something that reveals the world, but as something that defines the rhythm of reality itself. From here, there is another realization waiting, that the same light guiding our clocks also threads through the tools we carry in our pockets. That you have, at this very moment, a device in your hand which depends on relativity and quantum precision to tell you exactly where you are. And so the path leads onward to the GPS in your pocket and the hidden physics that keeps it honest. The GPS in your pocket. Every time you check a map on your phone, you are using Einstein's theories. Satellites high above Earth keep time with precision only quantum clocks and relativity can provide. Without corrections for speed and gravity, your location would drift miles in minutes. You carry, without noticing, a living proof of physics in your hand. You open your phone, tap a map, and within moments a small blue dot pulses where you stand. It feels simple, ordinary. But behind it is a quiet symphony of satellites, clocks, and physics working together across the curve of the Earth. The Global Positioning System, or GPS, is made of more than 24 satellites orbiting high above the planet. Each one carries an atomic clock, a timekeeper so precise it drifts by less than a billionth of a second per day. Those satellites send out a constant stream of signals, each carrying the exact time it was sent. Your phone listens to several satellites at once. By comparing the time each signal arrives, it calculates your position with remarkable accuracy. The method is simple in principle. Distance equals speed multiplied by time. Light, in this case radio waves, moves at a fixed speed, so if you know exactly when a signal left the satellite, you can measure how far away it is when it reaches you. But here's the part most people never realize. Without Einstein's relativity, GPS would fail. Satellites experience less gravity than we do on Earth's surface. According to general relativity, this weaker gravity makes their clocks run slightly faster than ours, about 45 microseconds per day. At the same time, they are moving quickly around the planet. Special relativity tells us that this speed slows their clocks by about 7 microseconds per day. The result is a net gain of 38 microseconds every day. It sounds small, but in the world of GPS, it's enormous. If left uncorrected, that tiny drift would throw off your location by nearly 10 kilometers each day. Engineers build these corrections into the system. Every time you check a map, you are seeing the results of quantum clocks adjusted for relativity, matched to the speed of light, and calculated in fractions of a billionth of a second. It's humbling to realize that the blue dot you take for granted is proof of the universe's laws at work. Proof that time is not absolute, that speed and gravity shape its flow, and that technology can weave those truths into something you can hold in your palm. Every location search is, in a way, a physics experiment you're running without knowing it. An everyday demonstration that the bending of time is not just real, but useful, practical, necessary. And when you think of it this way, the phone in your pocket becomes a kind of compass, not only pointing you through space, but also navigating the gentle curves of time itself. From here, it's only natural to wonder, if relativity and quantum mechanics guide something so familiar, what happens when we follow these laws into the most extreme places imaginable? Into the places where space and time are stretched beyond recognition. The path now leads to the darkest edges of the universe, where light falters and seconds are pulled long to the mouths of black holes. Black holes and stretched seconds. Near a black hole, time slows almost to a stop. Gravity's pull bends not just space, but the ticking of every clock, even your own heartbeat. From far away you would seem frozen, caught in an endless approach to the edge. You step closer, feeling each second stretch into eternity. Imagine standing on the edge of a vast abyss, not a hole in the ground, but a hole in space-time itself. A black hole. Its gravity is so strong that not even light can escape once it crosses a certain boundary, the event horizon. Here, Einstein's general relativity reveals its most dramatic truth. Gravity doesn't just pull on matter, it pulls on time. The closer you are to a massive object, the more slowly time passes for you. Near a black hole, this effect becomes extreme. From your own perspective, seconds feel normal. Your heartbeat is steady, your breathing calm. But to someone watching from far away, those seconds are stretching longer and longer until they seem almost to stop. If you tried to approach the event horizon, a distant observer would never see you cross it. Instead, they would see you slow down, your image redshifting into deeper and deeper tones, fading toward black as the light from you struggles to climb out. From your perspective, though, you would keep moving. The pull of gravity would grow until no force could turn you back. Inside space and time trade roles, forward becomes inward, and all paths lead inevitably to the singularity, the place where our current understanding of physics falters. This strange stretching of time isn't limited to the impossible extremes near a black hole. It happens near any massive body, just far more subtly around planets and stars. But here, in the shadow of this cosmic giant, the effect is so powerful, it becomes something you can almost touch. Physicists have long wondered about the experience of someone falling toward a black hole. What stories would their clocks tell? What would it feel like to live in seconds that, to the rest of the universe, span centuries? This is not just theory. We've seen hints of it in the cosmos. Radiation flickers from matter spiraling into black holes, slowing as it nears the edge. And in the ripples of space-time itself, gravitational waves, we can detect the warping of time caused by massive collisions. Standing here in imagination, you sense the profound truth. Time is not fixed, and in some corners of the universe, its flow can be bent almost to breaking. But black holes do not just stretch seconds, they challenge our understanding of reality itself. If time nearly stops at their edges, what happens to the concept of now inside them? Do the laws we know continue, or do they give way to something new? To answer, you must step deeper, past the horizon, into a place where the rules you've learned so far may no longer apply. The twin paradox. Two twins set out on different paths. One stays on Earth, the other travels close to light speed. When they meet again, the traveling twin has aged less, not in theory, but in measurable fact. It's a story that reveals time is not the same for everyone. You step into their reunion feeling the bittersweet weight of lost years. It begins like a thought experiment in a quiet classroom. Two twins stand side by side, their lives moving in perfect synchrony, heartbeat for heartbeat, breath for breath. Then one boards a ship. This is no ordinary ship, but one capable of moving at speeds close to that of light. Its engines burn with steady determination, carrying the traveler farther and faster than most can imagine. For the twin who stays on Earth, days become months, months become years. The seasons turn, and the quiet passing of time feels normal, inevitable. But on the ship, time itself is different. Special relativity tells us that motion through space slows motion through time. The faster you move, the slower your seconds pass compared to those of someone who remains still. To the traveling twin, the journey might last only a few years. But when they return to Earth, they find their sibling has aged decades more than they have. This is not science fiction. It's a consequence of the same equations that keep GPS satellites honest, the same laws that stretch seconds near a black hole. Experiments with fast-moving particles have shown it clearly. Their internal clocks slow compared to particles at rest. The paradox is not a contradiction, but a reminder that time is personal, that it depends on the path you take through the fabric of space-time. The symmetry is broken because the traveling twin experiences acceleration and deceleration, shifting between frames of reference, while the twin on Earth does not. You imagine the reunion, two faces once identical in age, now marked by the gap between their timelines. For one, the years have been long and full. For the other, fewer moments have passed. It is a meeting tinged with joy and with an unspoken sense of loss for the years they did not share, for the moments one lived without the other. In this story lies something more than physics. It's a meditation on how even without spaceships, we all live in different flows of time. Our choices, our paths, carry us through life at speeds that sometimes pull us closer together, and sometimes set us drifting apart. And so the twin paradox becomes not just a lesson in relativity, but a mirror for the human heart. It shows us that time is not only measured in seconds and years, but in the shared moments we keep, and those we miss. From here, your curiosity turns outward again, to the places where these distortions in time are not thought experiments, but natural features of the universe, written into the dance of stars, planets, and galaxies far beyond Earth. Time dilation in the stars. Far from Earth, in the deep gravity wells of massive stars, time flows differently than it does here. The dance of galaxies, the orbits of pulsars, even the life of a star itself are shaped by the bending of seconds under speed and gravity. You travel among them, listening to the quiet ticking of cosmic clocks. Imagine standing on the surface of a neutron star. It is only a few kilometers across, yet it holds more mass than our sun. Gravity here is so intense that your weight would be billions of times greater than on Earth. But it is not just your body that feels this pull, your seconds do too. Time itself slows in the grip of such a massive object. An hour spent here would be many hours or even days for someone watching from a safe distance. The star's gravity bends the space around it, and with that bend comes the stretching of time. This effect shapes the lives of stars and the rhythms of galaxies. In binary star systems, where one partner is a dense remnant like a neutron star or black hole, astronomers must account for time dilation to predict their orbits. Without it, the math simply doesn't match what telescopes see. Even light from these places carries the mark of slowed time. It leaves the star slightly redshifted, its waves stretched longer by the climb out of the star's gravity well. Every photon is a messenger, telling us not just where it came from, but how time flowed where it began. You might think of the stars as eternal and unchanging, but their lifespans too are bound to time's bending. A massive star, spinning rapidly, experiences relativistic effects that alter its rate of burning fuel. Its heartbeat, the fusion reactions in its core, ticks at a tempo set not just by physics in the furnace, but by the way gravity and speed mold its seconds. On grander scales, entire galaxies carry clocks that do not match our own. Stars on the outskirts orbit more slowly through weaker gravity. Those near the dense center experience the stretching of time. To us, their years pass differently, even if we can't feel the change in our own bodies. Astronomers use these variations as tools, measuring time dilation to map the mass of objects too dark to see, or to confirm the predictions of relativity in places so extreme they test the limits of our understanding. And here is the quiet truth. Time dilation is not rare in the cosmos. It is happening everywhere, woven into the movements of stars and the growth of galaxies, shaping the music of the universe in ways we are only beginning to hear. From where you stand, whether on Earth's gentle curve or in imagination beside a neutron star, it's clear that time is not a single metronome. It is a symphony, each note shaped by speed, mass, and motion. And if you follow this music far enough, it leads you home again, to the question of how to live once you understand that your time is not fixed, but a flexible thread in the vast fabric of the universe. The long journey home. After wandering through warped seconds and distant stars, you return to the small, steady rhythms of Earth. Time feels different now, more fragile, more precious, more shared. You carry the quiet truth that every moment is part of something larger. The return is never as sudden as you expect. There is no sharp break between the vastness you've traveled through and the familiar ground beneath your feet. Instead, it's a gradual settling, like a tide receding, leaving behind the soft imprint of its touch. You walk under the same sky you have always known, but you see it differently now. The blue above is not just atmosphere. It is the thinnest veil over the endless black you've crossed in thought. The sun's warmth on your skin feels like a message sent across millions of kilometers, arriving exactly when it should because light keeps its promises. In your pocket, a clock ticks in step with satellites high above. On your wrist, a watch marks the seconds in Earth's gentle gravity. You know these devices are only approximations, that your time and another person's are never perfectly the same. Yet the differences are small enough here to be a comfort, reminding you that even in a universe of bent seconds, there are places where time holds still enough to share. You think of all the ways the cosmos sculpts time, the pull of gravity, the rush of speed, the quiet threads of entanglement binding particles far apart. And you realize your own life is shaped by the same forces. Your choices, your travels, your connections pull and stretch your moments in ways both subtle and profound. On Earth, you cannot feel these changes in your bones, but you can feel them in your heart, in the way some days race by in a blur, while others open wide and endless, in the way a single conversation can feel outside of time, or a single absence can seem to last forever. It's easy to believe that time is something we simply spend, but now you know better. Time is something we inhabit. a living space we shape by where we go, how fast we move, and what we choose to hold close. The journey home is not the end of the voyage, it's the moment when you carry the universe's lessons into the life you already live. You find yourself listening more closely, noticing the light on the walls, the texture of voices, the pause before answering a question. Even here, in the quiet gravity of home, time is bending, and you are part of the curve. And perhaps this is the truest gift of all these travels, to see that every second, stretched or compressed, measured by light or by heartbeat, is connected to every other. That you are never truly apart from the rest of the cosmos. The stars you have visited are still out there, their light still traveling toward you. And one night when you look up, you might catch a photon that began its journey long before you were born. You'll know then that in some quiet, patient way, the universe has been coming home to you too, living with time's flexibility. After seeing time stretch, slow, and weave across the universe, you begin to wonder how to live knowing it is never fixed. Each moment feels less like a number on a clock and more like a choice in motion. You step into your days with a gentler pace, aware that you are shaping your own current of time. At first, the knowledge sits in your mind like a fact in a book, interesting but distant. Time is flexible, you remind yourself, bent by gravity, molded by speed, stretched by the quiet laws of physics. But here on Earth, in the rhythm of familiar mornings and evenings, that truth feels invisible. Then it begins to surface in the small details. A day spent waiting moves differently than a day spent in joy. The walk home at dusk feels longer when you notice the way light pools in doorways. A single conversation can vanish in what feels like minutes, only for you to realize hours have passed. Relativity is not only about stars and black holes, it's also about how we move through our own lives. Physics teaches that your path through space-time shapes the time you experience. Life teaches that your attention, what you choose to notice, what you choose to carry, shapes it just as powerfully. You begin to think of your days as a kind of personal orbit. Some choices draw you closer to the present, slowing the rush of seconds. Others fling you outward, hours disappearing before you even notice they've left. And maybe that's the quiet gift hidden in the science, awareness. To know that time is not a single unyielding thread, but a fabric you move through, one that stretches, folds, and twists with you in it. From the universe's perspective, you are just one point in a vast weave. But from your perspective, you are the center of your own flow of time, the one who can decide where to linger and where to move quickly on. It is tempting to want more of the fast moments, to chase only the exhilaration of motion. But you've seen what speed can do, how it shortens your personal clock. You've seen how gravity too can hold you so tightly that time slips by almost unnoticed. So you begin to look for balance, for days that move with enough momentum to keep you alive and awake, and pauses deep enough to feel the stretch of each breath. For moments that are long not because they are heavy, but because you were truly inside them. The science of time teaches you that no two observers agree exactly on how much of it has passed. The life of time teaches you that this disagreement is not a flaw. It's the beauty of perspective. Each person carries a slightly different universe of seconds inside them, and so living with time's flexibility becomes less about controlling it and more about traveling through it with intention. You cannot make your seconds longer or shorter in the cosmic sense, but you can fill them, shape them, bend them inward to hold more of what matters. When you look back, you want to see a trail of moments that felt alive, whether they were stretched thin over years or burned brightly in the space of an instant. Because in the end, the most profound truth you've learned is not that time is flexible, but that you are too. You, the universe, and the quiet return. After traveling through the strange landscapes of time and connection, you return to yourself, but changed. You carry the knowledge that you are part of the same fabric as stars, black holes, and photons, and in this stillness you feel the universe breathing with you. It is strange to return to the place you began and find it both the same and entirely different. The streets, the walls, the light of the afternoon, all familiar, yet they seem to carry the weight of the distances you've crossed in thought. You've stood at the edges of black holes, watched photons race without ever aging, felt the slow bending of seconds under gravity's hand. You've seen particles whisper across space without a signal, and learned that the rules of the universe are sometimes only temporary scaffolding. Now, here, in the quiet of your own breathing, you understand something that feels larger than all of it. You have never been separate from those places. The laws you explored out there are the same laws at work in your own body, in the patterns of your heartbeat, in the way your cells exchange their quiet signals. Your atoms were forged in the cores of ancient stars and scattered across space before Earth was born. Somewhere their siblings may still drift, in dust clouds, in the light of distant suns, perhaps still entangled with you in ways we can't yet measure. It is easy to think of the universe as out there, vast and unreachable. But the truth is that you are inside it, woven into its weave, part of its story with no clear boundary between you and everything else. Living with this awareness changes the scale of things. The small frustrations that once filled your days now seem like ripples in a larger sea. The moments of joy, a shared glance, a familiar voice, the smell of rain, feel like luminous points in a constellation you carry with you. You begin to notice time differently, not as a single straight line pulling you forward, but as a living space you move through, sometimes faster, sometimes slower, always shaped by where you are and how you are. And in this noticing, you find yourself slowing down, letting the seconds stretch a little longer when you are with people you love, or when you are alone under the stars, feeling their light touch your skin after millions of years of travel. The journey has shown you that the universe is vast beyond measure, but also close enough to touch, because you are already touching it every moment of your life. And so the quiet return is not really a return at all. It is a recognition, a soft, steady breath shared between you and everything else, in which you realize that home is not one place, but the entire fabric of existence. You close your eyes and the dark you see is not empty. It is filled with threads stretching from your fingertips to the edges of the cosmos, each one humming with the quiet truth you've carried back. You were never alone in space or in time, and you never will be.